Welcome to GCNTech. In this video, we are going to be diving deep into the subject of drivetrains with Marginal Gains expert and engineer Josh Poertner.
We're going to be asking Josh loads, including how chains and lubricants actually work, which lubes are best to use and when, as well as how to clean and care for waxed chains, and what the future may hold for drivetrains.
Josh, thanks for joining us.
Thanks for having me.
So in this video, we want to focus on the most important aspects of our bikes, the drivetrain, the part which actually makes it go. So the most obvious place to start and discuss is, Josh, explain to us about the demands which are placed onto the system and what it is it's trying to achieve.
Oh, wow. So you can think about, you've got your legs putting the power down, right?
Yeah.
And you've got to turn that rotational movement into a linear travel of something, chain or a belt, say, and then back into rotational movement at the back end, provided we're not talking about shaft drive or something crazy like that. But it just ends up being a ton of moving parts, and I think that's the one thing people don't always think about when you think about your chain. A typical chain is 116 links, and each link is 2 side plates, right? 2 pins, 2 inner plates, and 2 rollers. Right? So it's a ton of moving parts that as you're pedaling, say at 100 RPM, that chain is going from straight to articulated to straight again, and then over the pulleys, it's articulating straight, then straight, and then onto the cog, right, where it's taking all of the load, and then running across the top span again of the drivetrain under incredible load. So the forces inside of a modern bicycle chain can be somewhere on the order of 40 to 50,000 PSI.
That's crazy.
Crazy.
Now you can see why it's important to get lubrication right on that.
Yeah. And I think people ask all the time, wow, the chain is still made of steel? I mean, it hasn't really changed over the last 100 years other than getting much, much smaller and lighter. But yeah, you think of those numbers, 50,000 PSI.
So as well as it taking drive from us making the bike go forwards, it needs to work with a selection of different gears, work in loads of different conditions and environments. So how is that something that affects how we should care and maintain for the chain?
Yeah, one of the challenges, especially with the modern geared drivetrain, right, is you think we're packing, now in some cases 13 speeds into not much more space than we were packing 7 and 8 speeds years ago. And so everything's gotten much narrower, much thinner, including the chain, side plates, and inner plates. But in order to shift, there has to be enough gap and play in the chain that the chain can laterally articulate itself to climb from one cog onto the next cog, and then back down again. And so you not only have incredible tolerance and size control in the chain, but you also have to have very controlled gaps in the chain, which is why if you take the chain and say you put it on its side, it will actually take on a slight arc, and that's the stack up of all of those little high precision gaps. But then, of course, the chain isn't sealed like a bearing, and so we now need to lubricate it, and now that lubricant has to perform in a completely unsealed, exposed environment.
It sounds to me, I'm not a lubricant expert, but it sounds to me that there's a lot of demand placed on that lubricant from an engineering perspective, because in a lot of other environments, like say automotive or aeronautical engineering, you wouldn't have that chain exposed to the elements, right? So how does that affect the sort of lubricant and how you design a lubricant and stuff?
I think it pushes us to think really differently than we would for, say, a bearing or something in a much more controlled environment. And the state of modern wax, chain lubes has kind of settled on wax, which, interestingly, we can trace the roots of wax-based chain lubricants all the way back to World War II. You think of like the B-17 bombers and these things with these chain-articulated bomb bay doors. That was all being lubricated with paraffin wax because it was cleaner, but also just with all the petroleum shortages and everything else, greases and certain highly refined lubricants were going, for engines and things, and they were using everything. In some cases they were using tallow and animal fats.
Wow.
to try to, and you can actually get waxes from fats, similar to like a soap. And that was being used to lubricate those chains. And so as we fast forward to modern times, the real advantage of wax lubricants are that they are solid and they're non-sticky, right? As you think of, we're getting dirt and dust and things landing on our chain, we don't want it to be sticky to where all that stuff's going to stick onto it. And so a solid lubricant like wax can run much cleaner than other types of lubricant.
It's interesting because, like Ollie said, in lots of other industries, a chain system like we have on our bikes, you'd immediately put that into a casing to protect it, wouldn't you? But it's just not possible on a bike. Yeah.
So when you mentioned that chains have to have that sort of play in them in order to be able to, angle and go over the range of cassette, what's the difference in efficiency between, say, a track chain, a single-speed chain, versus one with sprockets on? And as we increase the number of sprockets, is there a trade-off as chains get narrower? Do they become less efficient?
Ooh, those are good questions.
Yeah, that's good.
So in the single-speed chain, the gaps that are designed in can be smaller because the chain doesn't have to articulate, and they also can be made more square, so you have more surface contact area within the chain, and that allows you to spread the load across a larger surface area of lubricant.
So that's why single-speed like track chains are wider.
Super wide, yeah.
Well, I would say that's more historical. You can run a modern 12-speed chain on the track if you wanted to and had the right, kind of cog and front chainring. So some of that's history. Some of that is that there is efficiency to be found with that increased internal surface area. And then also, just running it as straight as possible. We look at these, Olympic level track bikes. I mean, the precision, the 10th millimeter spacers and things that they'll put into the drivetrain just to get it perfectly aligned. I mean, that really can make a difference in systems like that. And then you get into, this sort of trend that actually the British team rode this past Olympics, but was really something that Shimano developed way back in the late 70s of a 10 millimeter pitch chain, which it's instead of half inch, so it's shorter links, which mean that each link has to articulate a smaller angle as it runs through, and so that it can really also improve efficiency.
Yeah. So but the narrowness, there's not like an efficiency loss that you're aware of going from say 12 to 11 to 10.
Not necessarily specific to that. I think if you've got the wrong lubricant or no lubricant, you probably are going to see faster wear, and you're going to see higher PSI, right? Higher pressures inside, or I guess higher direct surface contact forces inside of the narrow chains, just because everything's so much smaller. So yeah, from a 6-speed chain to a 12-speed chain, it's probably something on the order of, call it half, to make an estimate of the surface area across which you are now trying to put the same load. So it's more stress on the metal for sure, but from the lubricant's perspective, right, which its job is to keep the metal from touching the other metal, the pressures are double what they were just a few decades ago.
So speaking of the lubricants, a lot of the research has been done into sort of additives improving the lubricants. So how does that work, and like what sort of additives are being used?
Yeah, so I would say the original additive was probably graphite, going way back to the 60s. And, graphite's just essentially ground carbon.
I'd say, is that stuff in pencils?
It is, yeah.
Yeah, or use it to lubricate locks and door hinges a lot of times, right? And it's great as a dry lubricant, but if you add it to an oil or a wax, it makes a great lubricant additive. And it's just a hard... generally, you want the shape of the additive at the microscopic level to be platelets. And so you think of little hard platelets that can slide across each other. And they really just serve to kind of add as a barrier between the two metals, right? In an ideal world, you think of like if you had a spinning ring with oil on it and you put a load on that the oil would form sort of a hydrodynamic wedge between the two pieces of metal. And in theory, they never touch. That's great in theory, but of course in practice, it doesn't work that way. And so as you add additives like graphite or PTFE then becomes really popular because it's quite lubricious.
But nasty for the environment.
But
Yeah,
nasty
not
for the
good,
environment. Molybdenum disulfide was probably the next level of that.
That seemed. I remember there was a period that
yeah.
was like the whole they were dusting them like the white ceramic speed chains, aren't
On the
they? They
outside,
dusted with molybdenum disulfide on the outside.
That's actually I can't answer for them, but that's either a PTFE dusting or there's another. I'm totally blank on the additive at the moment. Actually, it's used a lot in cosmetics. It'll come to me.
I don't know why you looked at me when you try to guess that.
Yeah,
I don't
Alex will know.
Yeah, Alex will know. He knows all about the cosmetics industry.
But there are a handful of sort of white to light gray friction modifiers in the market, and then molybdenum disulfide or moly it's pretty dark in color. Tungsten disulfide is like a super dark gray in color, and so you can tell typically those lubricants or lubricants with that added are quite dark, and unfortunately a little bit they tend to look dirty.
So is that why this is the colour it is?
Exactly.
That's so the super
tungsten
secret
disulfide. Yep.
wax.
Yep.
It's just the colour of the additive.
The color of the additive. Yeah.
It's interesting saying about the dusting that's on the outer surface of the chains because, well, like you've just explained, the majority of the friction and where you want all this careful lubrication is right on the inside bits, on the rollers and the pins. So is the bit on the outside really having much impact on stuff?
It's really more there to keep external dirt from being able to stick to the wax.
Yeah.
You can see a small effect if you, say, dust your chain rings and your cogs with these additives, that you can get some small sort of surface hardening effects as like the tungsten disulfide will kind of embed into like a chainring or a cog.
On the teeth, sort of thing.
On the teeth, yeah, just from the contact in being in that high pressure contact area. But the effect there is really tiny, and we're talking 1/10 of a watt or less. But the effect of having that stuff on the inside in these super high pressure part of the chain, primarily between the pin and the inner side plates, that's where you kind of see the most force during articulation of the chain. That's where you want these additives. And so I would say the current state of the art there is really it's graphene is coming along, and then tungsten disulfide at a nanoscale, and then tungsten disulfide at a microscale, and then I think most molybdenum disulfide tends to be microscale. And so, you're seeing advantages from the particles getting smaller, and also from us getting better control over the shape of the particles, like making them more platelet-like, which is really the strength of graphene, right?
Yeah.
Single layer carbon atom, it's one atom thick plates of graphene.
Yeah. Whereas on a microscopic scale, like graphite, I'd imagine it probably more like irregular, more shards.
Chunky. It's it's kind of a little bit more round and chunky. Now, interestingly, graphite under high pressure can exfoliate itself into graphene or near graphene.
How graphene was made.
Yeah, sheets.
Yeah.
But as it starts out, it's kind of looks more rock-like if you were to look at it under a microscope.
So far we've been discussing on how a lot of these high performance lubricants are working to reduce friction, and it can make bike chains faster and more efficient and improve people's speed. But I guess some people are going to look at this and go, well, I don't do racing, I'm not interested in all that sort of stuff. But by taking the same care and principles and approach to your chain, not only is it going to make it faster, it's going to make it last longer. So it's like is it like a twofold advantage whether you're interested in speed or even just longevity of products? You're getting the same sort of results?
Yeah, and I think the interplay here is kind of fascinating in that the fastest lubricants end up also being the lowest wearing lubricants. And so you really get this powerful kind of double effect, right? You might be saving, you think of like some of the worst traditional dry lubricants as they were called. And there's a lot of independent data out there on this, but some of them your chain might run in the 12 to 15 watts of loss on a 250 watt input.
Yeah.
And some of the best lubricants currently are in the 3 to 4 watts of loss. But when you look at the drivetrain wear, it can be a factor of 10 or more improvement to use the faster lubricants. So you might get 10,000 kilometers out of a chain instead of 1,000 kilometers out of a chain.
Which is a lot.
That's nuts,
That's
isn't
crazy.
it? Yeah.
Especially, I think, when people look at the bit more a process involved to cleaning and maintaining the chain, and you think, well, it's going to make it last longer. So irrespective of being a racer or not, it seems like a really good way of making saving yourself some money and being better for the
Well,
environment.
just practically the fact that they stay cleaner for longer.
Yeah.
Well, you don't have to clean it as often,
Yeah.
which is just anything for an easy life. So the other thing that I think is interesting is when you talk about drivetrain losses is I'd imagine that most brands and data that when it's supplied, not all, some do look at this, just would give us the figures of like the perfect scenario. So they've prepared the chain, it's all immaculate clean, you could eat your dinner off it, and then they lube it and then they put it on the rig and they go, oh, it's like this efficient.
Yeah.
But that's not real life. You're doing, Paris-Roubaix or something, we just had it. At the end of something, a long ride where you've got dirt onto it, how does that difference change then in efficiency between the sort of best and the...
So like
the
best
not
and
best?
worst case scenarios.
Yeah.
Is that, okay.
Yeah. So the worst case scenario, if you think of the traditional dry lubricant, right? So it might be, you take we won't name names, but you can look at the side of the bottle and you see it's about 10% white stuff and the rest is a liquid. And that's typically like a heptane or a pentane, like a really fast evaporating volatile solvent. And then the lubricant is maybe wax and PTFE or boron nitride. That's the additive I was thinking of earlier.
You two love talking about
when they,
nerdy
talk
chemicals.
about ceramic dry lubricants would use like a cubic boron nitride. Anyway, but it might only be 10% lubricant, and so you put it on the chain, the solvent evaporates out, and you think of, we like to talk about the negative space in the chain, right? So because the chain needs to have play in it, there's all this empty space that you're trying to fill up with lubricant. Well, if I fill that up with something that 90% of it evaporates, I'm now only 10% full of lubricant. And what that means is that the side plate gaps, the gap at the pin, kind of all those gaps are now open to contaminants coming in because they're only 10% full of other stuff. And so worst case scenario are the traditional dry lubricants and the quote ceramic lubricants that they generally aren't the best lubricants at baseline, even when new and clean, but as soon as you start riding, every little bit of contaminant, or God forbid it's raining, water that gets on there now has all this empty space to fill. So your next step would be wet lubricants, right, where you can fill 100% of the space. But the problem with a wet lubricant is as the chain's articulating through the drivetrain, stuff that lands on the outside sticks to the oil and then can get stirred and mixed into the inside.
And then you get that grinding paste that wears the...
Turns into grinding paste. Yeah. So we've solved the one problem, right? So like in a zero friction cycling is probably the best independent source on the internet for this. But if you look at his testing, he's got clean testing, dust and dirt testing, and then he's got his wet testing. Oh, and then he's got wet, like muddy testing.
All the conditions.
All the conditions. And you can see the different lubes, perform really differently. Like some of them, are amazing in the dry and terrible with dust. Those tend to be the wet lubes. But then wet lubes can be quite good in water, but not in water if there's dirt because of this grinding paste mixing effect. The classic dry lubricants tend to perform poorly pretty much everywhere. And then you get into the what they call chain coatings or like drip wax coatings. And, like I know with our product, the Silka drip wax, it's about 65, 70% wax. And so you drip it on like a drip lube, and you're losing only about 30% of that space to evaporation. In our case, we use water.
Yeah. So you're keeping the good stuff in there. We got a bottle behind us here, the super secret stuff.
So it's about 70% full of wax, and then you've got the good additives and all that stuff in there. And then the holy grail is the hot melt dip waxing, where you've got really the best lubricant that's a solid, so nothing wants to stick to it, and you're getting the chain 100% full of it. So, the best way to think about it is dirt and water and other things cannot get into the chain if it's already full of other stuff.
Okay. So we've sort of touched on a few different things there. What I want to do is go and run through some different scenarios on what best lube to use in those scenarios.
Okay.
Right? But before we do that, can you give us as brief as possible sort of explanation of the three main types? So we've touched on hot melt wax.
Yeah.
You say that's the sort of holy grail of low friction, right? But what's the disadvantage of hot melt wax, like as you see it?
It's really just the effort. The chain has to come off the bike to go into the hot melt, and you really need a dedicated crock pot or some sort of, something to do the process in.
Okay.
That's really the only disadvantage.
Yeah. And then the next thing is the sort of a bit easier to do, like drip on wax.
Whoa.
Oh, I dropped it.
That's how Lubricant is.
Which is, yeah.
Sorry, that's a bad joke.
Yeah,
on my
that was
part.
quite good.
That's a good joke.
It's
Yeah,
good, good for me, actually.
So then you've got a drip on wax product, which is, it's the same sort of additives and molybdenum, tungsten disulfide that's in the normal wax, but it's just a different application process.
Yeah.
So you're saying you don't get as much penetration of that product into the chain links. You don't get as much sort of in there.
Right. And so the super secret, I think what makes us unique, and I don't want to be just a Silka show here.
Yeah.
This is similar. Ceramic Speed makes UFO drip. There are other brands out there doing a similar product that are really good products. In our case, this product is the secret blend, the hot melt, emulsified into water. So so that makes them compatible. So like if you're hot melting and you don't want to do it, you can actually use the drip wax as a top off.
Yeah.
But the challenge is, you get 100% of this gets into the chain, but then as it dries, 30% of it leaves.
Yeah.
And so, now you can do the math on this, and if you do a second application, you can get up into the mid 90% range because it fills up again, and then 30% of that goes away. And so with 2 applications, you can get almost
That's a really
to the
good
level.
point.
But with
of the
that, you
hot
do
melt.
need to get it. You do need to do it, like say, the night before, so that it can. The solvent carrier can the water can evaporate off the chain and it dries out.
Right.
So you need. So that's a sort of disadvantage of that.
What's
perhaps,
the-
for some
yes.
people in some instances?
Yeah.
And then the other thing is, the other one is, broadly speaking, like a wet lube,
That's what I was
which
going to
is
say.
you can apply
got
like
one here as well.
instantaneously and then
Yeah.
ride.
Exactly.
And it's
Something like
designed
this.
for wet conditions.
This is like a bit more of an oily-based lube, is that right?
Yeah.
Yeah.
So with that in mind, and those sort of 3 broad types, right?
Well, there is a 4th type,
right.
dry lube.
A dry lube.
We don't make it,
Yeah.
and I think we would never make it because it just doesn't work well.
Yeah.
You don't have to take my word.
No,
Look
fair.
at Zero
Yeah.
Friction Cycling, the biggest independent test out there. It's bad in friction, and it's bad in wear, and so that is another category we just choose to not.
So based off of those, well, we're going to say 3 categories.
Yeah.
If you're that strongly opinionated on the 4th.
Me strongly
Yeah.
opinionated.
So we've got sort of scenario 1, and this is something that we get asked a lot.
Yeah.
Say someone has got either a waxed chain or a drip waxed chain, so it's kind of set up for dry conditions. They've got a big ride, which they're definitely going to do. Maybe it's an event. They open the door, and unexpectedly, the forecast has changed, and it's absolutely tipping it down outside, and it's raining. We get asked, lube on lube. Should you then, what's the best thing to do? Leave the wax on there and go with that, or apply some, you don't have time to clean it,
Right.
so
Last minute decision.
last minute thing, do you put some wet lube on top?
I would not. We only recommend lube on lube for these like ultra distance events where
Right.
How
maybe
ultra are we saying?
like 400 plus miles.
Okay, right,
So
yeah.
a hot wax application, you should easily get 300 miles of high efficiency. Again, Zero Friction has great data on this, but single application, 300 is a safe number, even if it's wet and rainy. Your drivetrain will get a little noisy as the external, one of the things with wax is it's super quiet in the beginning because the wax is there kind of as a barrier between the rollers and the cogs. But as it loads up with dirt, it can't adhere to the metal as well and it falls off. And so people hear their drivetrain getting a little bit tippy-tappy and they think that that's the lubricant not working, but it's actually just the rollers touching the cogs and the chain rings a little bit more. But over 300 miles, 400 miles, you might want to take a oil-based wet lube and you can apply that over the wax and it will, because one of the things that's happening under load, the wax will eventually push its way out everywhere. And one of the advantages of that is that any dirt that's getting on the chain is continually kind of being expelled from the chain by the wax coming out. And unlike a wet lube, as the wax is being pushed out, it can't go back in. So, it's a little bit like you cut yourself and you're bleeding, You have the dirty wound, right? And the bleeding is actually helping clean
it out,
the wound.
okay.
The wax kind of is doing a similar thing.
So you say 300
the
miles
chain.
is the sort of rough point where you think, okay, a wax-based lubricant is going to start to struggle.
Yeah.
Okay, that's fair.
So yeah, if it's raining and you're doing a sort of Gran Fondo or something, or a time trial, just keep your wax on.
Just keep your wax
Yeah.
on.
Wax will be good. Okay, well, what about something off-road? Like I'm talking
Unbound. Yeah.
Connor's doing Unbound in the summer.
What advice should you give?
Because I think
to
most
Connor?
people are going to go wet lube. It's off-road.
It's off-road, yeah.
Yeah. We work with a lot of those athletes, and I will say I think the entire top 10 men and women last year at Unbound, all on hot wax.
Yeah?
Right.
All on hot wax.
And is
Hot
that
wax
because it
will
doesn't attract
easily-
the dirt?
It doesn't attract the dirt. It's much faster, and you do have the ability to put an oil-based lube over it. And so I know certainly for our athletes, we'll put at the last aid stations, have a guy with or a girl with a bottle of our Synergetic, and if the drivetrain is sounding noisy or the riders have any, it's kind of almost as much psychological as real, but you can get that oil on at the end. But the difference, you can go the full 200 miles on a wax chain, especially if it's just dry and dusty. And the chain looks almost no different at the end of the race.
That's the
than when
best
you
bit for me,
started.
is that you don't end up with this oily mess all over your bike.
Yeah.
I think that's the best thing.
So something I'm particularly interested in is I'm doing in the summer the Tour de Station again, which is an ultra fondo in Switzerland that takes in like all the passes, except it was the equivalent height of Everest. Now they've got a crazy one that's called the Tour de Station like Ultra 1000. It's 1,000 kilometres
Wow.
with 3 Everests equivalent elevation as quick as you can. So this is going to take me more than one day, and this is a pretty extreme scenario, right?
I just thought of something that I'd
What?
say, yeah.
What if you were doing this with all your lube knowledge? What would you do?
I would start on hot wax and then transition to a wet lube with continual wiping.
Because so why not topping up with the drip-on lube?
So the drip wax typically takes a good 8 to 12 hours to dry. And so adding it wet and then riding, it's really just going to come back out again.
Right.
Because it has to be thin enough to penetrate. And because it's water-based, it doesn't have the viscosity to handle the pressure like the oil-based lubricants do. You could certainly also start with a wet lube. The key really to an event like that is a small microfiber cloth and wiping and reapply before you reapply. Because otherwise, all that dirt and grit that's on the outside, when you're applying the wet lube, it's just going to carry it in. And so microfiber is much better at grabbing all those little particles than any other type of cloth or sponge or anything you would wipe the chain with. Microfiber really is a big advantage there. And I would say, give it a couple of cycles through the microfiber and then hit it with the wet lube.
I just had an idea as well.
Yeah.
So, presumably during this crazy event, you're going to stop at some point briefly. Why not prep 2 or 3 different chains, put a new chain on halfway around that's freshly waxed? If you're going to stop for like 10 minutes, why not just get a selection of chains prepped, ready to go, while you're having a little lay down and some snacks, you can get your helper, fresh chain on, away you go. I actually think that's quite a good idea.
That's a good idea. I'm actually totally on board with that. That's a great idea.
We've rambled on about lubricants and chains for quite a long time now. I think what I would like to just briefly do, Josh, is pick your brains on how do you see the future of drivetrains evolving? Do you think that the chain, as we sort of see it in its general configuration now, is going to remain for the years to come? Or do you think there'll be some crazy designs that actually come to fruition? We've seen the ceramic speed shaft system that hasn't really come to life. Do you think we're going to see more stuff like that? Do you think belts are going to come in? Internal gearboxes? You name it, you go for it.
I don't foresee the chain going anywhere anytime soon. I have to say I actually have, for myself and my daughter, belt drive bikes with internal gear hubs, and that is an amazing system, but the losses are just too great for racing. I think that's one of the things not fully maybe covered with some of the internal gear I don't know, excitement that's happening now, but like a really efficient planetary gear system is 92% efficient. I mean, that's terrible compared to a traditional chain and cog style of drivetrain. So unless there's some major advances there for racing and high performance, I don't see that coming. Shaft drive is interesting, and I'm really good friends with the folks at Ceramic Speed and Jason Smith, who's ex-Friction Facts, now running that project for Ceramic Speed, and I think it's one of the coolest, most exciting.
So that's still an ongoing.
It's still an ongoing thing.
Wow.
I thought it had died a death. No, that's really cool.
They're still working on it, and it's fascinating. The complexity level is so high that it's really hard for me to see it becoming that big of a thing. I mean,
I think in its defence, I think if you were to look at now, like a Jura Ace rear derailleur and the shifters and all of that and all the ramps and complexity on the cassette, and if you were to, say if we'd, in an alternate reality, alternate universe where they went down the shaft drive route, 100 years ago, and then all of a sudden Ceramic Speed went to Eurobike and brought Jura Ace prototype along with it, with a cassette and a chain, people would be like,
what the hell?
The complexity of that is far too high that I can't see it ever coming to fruition. So,
I think the challenge there is can they buy themselves enough time to get it to market at the level
that's required.
That's required.
So why is what from an mechanical engineering standpoint? Why is the shaft drive with a viable option in terms of efficiency?
The way they're doing it, all of your contact points are small bearings. And so it really gives you the ability to reduce friction at all of the contact points, but you're also simplifying it. You think now, the chain as it works around, right? It's articulating at the top of the chain ring, articulating again at the bottom, at the pulley, then it's going straight onto the next pulley, right? And so it's articulating over and over again. And it's a simple contact. It's a pin in a hole. And so theoretically, that's line contact as it's rolling. But as we all know, in practicality, there's actual slipping happening, and that's why the chain wears out. What they're able to do is have little bearings at all those points, so it's always line contact because everything is rolling theoretically. And so it's a brilliant system in concept, but the challenge, of course, being that the gear shift mechanism and the tooth profile and the way they have to make that cassette, for lack of a better word, just get extremely complicated. And then you have the challenges of, they're using sort of almost like a bevel gear tooth shape, which is using some very cool math to control the rolling and making it always line friction. Well, that becomes really challenging with dirt. And of course, it has to be exposed because we're not encasing things. And so you do get back to a lot of the traditional challenges there. I think we just saw too, the Ceramic Speed has this interesting patent on a chain with a sort of 3-piece pin system where you're getting this sort of rocker mechanism in there. And that's fascinating as well. And I think there's probably some real potential there. But again, you think of a single chain having so many hundred components, and now you've tripled the number of components, and now they can't just be simple lathe-turned round things, and it's bloody hard to make something round. I think people forget about that, but like just round is hard enough. And now having to make 3 highly precise, kind of semi-parabolic shaped things that at a certain level of surface finish, after they've been coated with size control, it gets...
We're going to see a chain that's like 1,000 pounds.
I look at that and think it's brilliant, but I don't see how we can make modern chain for what it costs. Like a Dura-Ace chain today, I cannot figure out how they make it as cheap as they make it. With the precision, the tolerances, the coatings, the metal. It's amazing. I think
maybe the bike chain is just one of those things that it just works and it's been refined so much that it's near impossible to.
And we take it for granted. A lot.
Absolutely.
Wow. There you go. What a time to end. Josh, that's been incredible. All right, thanks. I've enjoyed speaking through that. Ollie, had a good time?
I'm now going to be hopefully faster in my big event this year, so...
We better get a wax on those chains for you.
Yeah, that's right.
Right, let us know in the comments section down below on what you think is the future of drivetrains, and we'll pick those out on a future show. See you later.